Here's a demonstration of how you can merge it, align it and merge it using EMSE. We're going to do it in a command mode, a GUI-less mode, so that you can integrate it into your processing pipeline if you want to use it. But we'll start with entering a trial code. So after you've downloaded and installed EMSE 5.6.1, you'll launch it, and then we'll just enter a trial code to get going. I've got one here. Okay, this trial code will last for about a week. That is, it can be entered for about a week, but we can always get new trial codes as needed. Okay, so the other thing I provided for you to download is this zip file called EMSE-570 zip. It basically contains, here's what it is. I've put it on my computer. I've put it in a folder off the C drive called test /EMSE-570. And basically the main content is in this folder called input. This is what you provided, Dylan. It's got a BDF file for the EEG, and it's got some live tracking data, these two files. In addition, it has a batch file called sync.ts.bat. So this is what we're going to use in the command processing mode. And that batch file just contains this single line. So after you install EMSE, in the program files directory, there's an executable file called EMSE_SE.exe. The second SE stands for scripting engine. So it's a GUI-less program. It's just designed for executing scripts. Okay, so it's going to have a few arguments. The first argument here, we give the full path to where a script template exists. So actually, here in this folder, here it is. And in the batch file, it doesn't list the extension, but the extension needs to be .template.xml. And here I am. I'm looking at it in Notepad++, and that's a nice editor. If it has an XML extension, it will parse the tags out. Okay, so just a quick look at this script template. The script template has a part at the top here, well, list of string variables, and then the script itself is below. But the string variables, there's a string variable abbreviated as in that corresponds to our input folder, which already exists. There's another string variable called out, which corresponds to it'll correspond to a folder to be created. Actually, it's going to get created right away here. This make directory command is going to make the folder called output, and these single $ tags are replaced with the value here. Okay, so those two string variables are fixed in the script template, but what makes this a script template is we have some other variables with double $ tags that will be filled in from the command line of the batch file. So we have a second parameter called template that just tells us that we're in the script template mode. And then all the other parameters are going to be used for filling in the template. So this next one, so we'll start numbering from here. So this will be 1, 2, with white space between 3 and 4. So we'll have 4 additional parameters from the batch command line, and they will be here. So the first one is going to be correspond to this first one here after template, 226. So that value will get filled in here, and it will have the abbreviation SID for subject ID, and then it will be used subsequently down script. For example, here this single $sign SID will get replaced with 226. Okay, so that's basically how it's going to work. This is a template because these values need to get filled in. So we'll have another string variable. We'll give it the abbreviation EEG. It's going to get filled in the $2. That's the second parameter here, and that's this one. Okay, so this happens to be the unique part of the EEG file. If we look in the input here, this is the EEG file, and this portion here is needed to specify the EEG file. It's the second parameter of the command line, and in the script template we give it the abbreviation EEG, which down script, for example, here. So if we look then at what this line indicates, where this first command is going to simply copy from the input folder to the output. You don't have to do that, but I just wanted to keep the input nice and clean, and we can practice. And it's easy to get back to the starting point by deleting the output folder, which will end up having a lot of other stuff in it, and then the input folder will stay clean. So that's why I did it that way. So this first command is just going to copy from the input folder to the output folder and give it the same name. And you can see, oh, by the way, this means it's relative. The path is relative to where this script template exists. So the script template exists at this level. On my computer, it's has this path, and everything in the template itself is has a relative path to where this exists. So so you can see if you fill out these single $signs string variables from above, this will expand to be the name of the EEG file that exists in the input folder, and then we'll give it the same name in the output folder, which gets created here. Okay, I think you get the idea. The third parameter from our command line here, this is the unique portion that describes the eye tracking here. So it's basically this string here, and we can use it together with the subject information, and we know this is a fixed, this underscore meta is fixed. So what we really need is this part, and that's what we're provided in the third parameter, and the third parameter, that value will get filled in here, the double dollar sign. It will get the abbreviation live track, which then gets used down script here. So we're going to do the same thing. We're going to copy the live track data also to the output folder, and also the meta.txt, and this display preference that comes later when we want to view the data of the merged results. These display preferences I'll just mention. We don't have to look at those, but these display preferences here will do things like give different channels different colors so we can look at them differently, as you'll see. It's more for the convenience of display, and you don't have to use it in your application. But here's the main command. Okay, the main command is called sync time series, and it has several parameters. So the first parameter is called the reference time series, and we're going to work with the ones that we copied over to the output folder. The reference time series is the EEG. The relative time series is the live track. So that means we're going to be aligning and resampling the live track data to match the EEG. Okay, so that's why the EEG is the reference and the live track is the relative. The results are going to go into a new file. We'll start by naming it with the subject ID using that same convention, but we'll give it the merge name. That's the final argument here, the fourth argument. That you can call it whatever you want, but this will be where the results go. And in the script template, we have a string variable. It gets filled in with the double dollar sign, which comes from the command line. Gets filled in. We abbreviate it as merge down script, and that's what gets filled in here. So that's where the results will go. Now we have some other parameters here. The next two parameters are what you might call quality control parameters. So the alignment procedure, it's going to look for common events, common event codes, events codes that are in common between the EEG and the live track. And if we have codes that are in one and not in the other, we'll just ignore them. We won't use them for alignment, but we'll use all the common codes for alignment. And what this is saying, this parameter min common events, what we're saying by giving it the value 100, I just picked that out of a hat, but it's saying if we don't find at least 100 common events, we'll bail out, give an error message, and we won't proceed. And that'll you'll probably want to diagnose the reason for not getting enough events. Okay, so that's a quality control you can set. Okay, the next one is after alignment. So the alignment procedure is to fit a line through the timestamp data. The line will have us an intercept. That intercept will be the offset between the two data sets. One data set would start, say, at an earlier or later time compared to the other. That's the offset. The other thing we get is a slope, which we expect that slope to be very close to 1. It's basically if the two clocks are clocking at exactly the same rate, frequency, and the reported frequency that we that the software for Active 2 and LiveTrack are reporting are exactly the same, then we would get a slope of exactly 1. If the clocks are oscillating at a very slightly different frequency, or more likely if the reported clock rate that the software gives us isn't out to the same number of decimal points for each case, and we use those reported, then after a very long recording, it could go out of sync even if we've properly aligned them with the offset. So over the course of the recording, then we will fit a line through all the common events, and we'll get an RMS matching error. So in the end, we'll have root mean squared error of matching reported as milliseconds, and if the number we put here is another quality control. So if the RMS matching error we get out, the way I've said it now, if it's greater than 4 milliseconds, we'll bail out, give an error message, and you can look at it and see what went wrong. Let me show you. Okay, so actually let me change this to 1 millisecond. I will change that and save that. 1 millisecond is too good because the LiveTrack is sampling at 500 hertz and Biosemi at 512. So we don't really expect to get an RMS error of 1 millisecond. So I think this will generate an error, and you'll see what I mean, what happens when it fails. These other numbers are simply to rescale the results I'm using a factor of 10, just to rescale the trigger channel, the gaze channels, and the pupil channels into the BDF file. The BDF file is 24 bits, but we need to convert floating point numbers to the 24-bit, and we'll want to view it together with the EEG. So these numbers I put in there are simply to rescale those channels so we can see them in the EEG. The trigger channel, another reason for that is that when we convert it, when EMSE converts it to BDF, we don't want it to overflow. So we need to put a little something in there to scale it down. All right, the rest of the script, add to Workspace here. This is for convenience. You'll see we're going to create a workspace. That's what EMSE uses to organize the data. You won't need it, but if you want to look at the results, which we'll do here, you'll see what that does. Okay, so I think we're ready to give this a try. So I made this on purpose. I made this quality 1 millisecond. I'm expecting to see an error because I'm not expecting to get quality that good, and I'm doing that on purpose. All right, so we saw the batch file. Here it is, and I'm just going to double click on the batch file, and it'll start running. Okay, immediately you can see some changes here. So the output folder was created. This log file is generated by the script. See, these other two files were generated. This one, called script XML, is the template after filling in the variables. So this is an executable script. This is a template because it has the double dollar signs in it. And the status file, which we can look at any time, it's designed also for another purpose, so something called Job Manager. You don't have to worry about that. But you can see that the status now is it's processing. It's completed a few commands. and there weren't any errors yet at that point. Let's look in the output folder. We can see that it copied some files over. There's some .evt files. These are event files, so that extracted the events. Now let's go back here, and let's look at the status now. Okay, so our command prompt went away, so the script finished, but it failed. Okay, the job status is failed. Okay, we did that on purpose. And let's look here and see what the reason is for the failure. So we come down here to the error message here. And if we look down here, it says sync time series. That's the key thing we were expecting to find. RMS matching error exceeds the maximum error that we specified. The maximum error that we specified was 1 millisecond. And so that was too rigorous of a quality criterion. So let's say, okay, let's go back and let's give it, say, a more reasonable one. Let's say 3 milliseconds. We know we're sampling at 500 hertz, 2 milliseconds. Let's give it a little bit of leeway. Let's say 3 millisecond leeway. Let's see how that works. And we can run it again. Now, I could just double click on the batch file again. That's fine. But let me go back to where I started. Where I started, we didn't have this log file. We didn't have these. These were generated. We can regenerate them. They'll be overwritten if you don't delete them. Okay, so now we're back to where we were, except in my template. Now I've set the quality criterion to be 3 milliseconds. Okay, so now let's run the batch file again. Once again, we get our files. If you want to look at the script while it's running, let me look at the script that was generated, just to see the difference between this script that was generated and the script template. The only difference is that the script that was generated has filled in these values. See, so where the subject ID in the template was $$1, that first parameter, it filled that in as 226, etc. For EEG, it filled that in, live track filled that in, merge filled that in. That's the only difference, and then down script, all this is the same. Okay, let's look at our status. We can look at our status. It's okay to do it while it's running. That was designed, the status was designed to be interrogated during the execution of the script, so that's fine to look at it. So we can see what happens. There's some timestamps here. We can see at the time I looked at the script, it was running 24 seconds worth elapsed time. Okay, and it says processing, so has not finished, it's processing, and I can close it down. Still running. Okay, now, you see when these two files appear, these temp files, these are called stacked meta files. These two files are intermediate. This is an intermediate step for merging the aligned live track data. So when you see that, it means the alignment was successful within our criterion, and it's going to be using this to generate the BDF file. And when it's finished, it'll delete these temp files. So you should see them go away. Yep, okay, so we lost our command prompt finished. The temp files went away. We now have an EMSE workspace where we can view the results. And if we look at the status now, it says it finished, completed. That means it was successful. And it took 2 minutes and 46 seconds. Okay. All right. Now, let's take a look in the output. Let's sort. Okay, they're already sorted by size, but as you can see, the largest file is the merged one, the merged BDF. The next one is the original EEG BDF. The next largest file is the .text file from LiveTrack. And then finally, this one, this BDF, it's an intermediate result that you can also use. It's a BDF file that contains only the eye tracking data, and it's already aligned to this one, but it's not merged. It only has the eye tracking channels. So basically, this one is the merger of this one and this one, then the original one. So the original one is not changed. The original EEG file is identical to itself. But so that's why we called it the reference file. But the eye tracking BDF has been aligned, trimmed, resampled to match this one, and then the two are put together in this one. These other files you can mostly ignore, except let me point out this one. This one's useful. It has the same name as the merged file, but it has this extension align.txt. And so we can look at it in Notepad++. And this contains the alignment results, and you can see what it's doing. So set1 stats, this corresponds to the reference data, namely the EEG. Here in the first column we have event codes that were found in the EEG data. That's the first. These are event codes in the order in which they were found. And then in the second column we have the number of events of that code. So for example, type 133, 9 of instances of that code were found in the first data set, the EEG set. 600 instances of code 125 were found, and so on. 10 instances of code 135 were found. Okay, now in the second set, this is the live track. Similarly, in the order in which the events were found, we see some event codes here that we don't see in the EEG. For example, let's find one. 96, for example. We found 5 event codes of type 96 there. We're not seeing a 96 up here. Okay, that might seem bad, except we have, if we look down here, we see the common stats. These are the event codes that have a common code, and they have the common number of codes found. And we found a bunch of those. In fact, there are 3,020 events in common. Okay, so we'll want to use only those 3020 events for doing the line fit. And you can see that in our template we set a quality criterion of at least 100. We've got way more than that. So if for some reason we had fewer than 100, it would have bailed out and given us an error message similar to the one we saw in this case. All right, now importantly, we'll see here the RMS match error is 1.43 milliseconds. Okay, that's good. It's certainly less than the 3 millisecond criterion we set, so it passed. But I think it's pretty good considering the sample rate is 500 hertz. Less than 2 milliseconds is for the root mean square match error is pretty good. Now on the line fit, this is the intercept. So 121 seconds, that's about 2 minutes difference. I forget which way it goes, but one of the two recordings started about 2 minutes before the other one started, and that's this latency shift. And then finally the slope I was mentioning, it's very close to 1, but these digits out here are important to keep the alignment in place over the course of the entire recording. And the sample rate 2 says 500. This is based on the timestamps. That means that the sample rate of 500 hertz of the live track, according to this analysis, based on the timestamps, it's a little bit faster than 500 hertz. And for the purposes of our fitting, it doesn't have to be exactly 500. Now, of the common events that we found that had the same event code in exactly the same number of instances, for example, now we've got the detailed results. So there were 9 of those of code 133, and these are the individual errors after doing the straight line fit. So most of these you can see are sub-millisecond errors. There's one that's a little over a millisecond. There's one that's 3 milliseconds. I still think that's acceptable. But these are all sub-millisecond errors. Now for the 125, there we had 600 of those. So here we have all the individual cases, and they're mostly sub-millisecond, a few larger, but you can look through them and they're all pretty good, and so on. For all those 3,000, all of the 3,020 events that were found in common between the two, those are the detailed alignment results. Okay, let's take a look at it. So now we can use EMSE to look at the results. What I'm going to do is open a workspace. That workspace was created here in our folder. And in the workspace we have 3 results. Okay, so there's the original EEG. We have the eye tracking only BDF, and here's the merged one. So let's look at the merged one. So I'm going to double click on this one. And if we were using EMSE to do the analysis, we'd probably say yes here, but let's just keep the data looking pretty raw, because I know you're using other software for the actual analysis. So I'm just going to say no here. And here we have here we can see what the display preference file that was copied over to match with this file. That's where these different colors are coming from. But we see we have EEG file channels. We're looking towards the end here, so we've got here EEG channels. We have a first event code of 201 close to the beginning. We've got eye tracking channels here. This is the ECG channel number 7. There's also a trigger channel. At first, what we really want to do is confirm that the triggers are well aligned. So to do that, let's just look at the trigger channel by itself. Let's go here. There's the trigger channel. Let's turn display of everything off except for the trigger channel. There, now we can see the first and the trigger channel. We've got the event code 201. That's coming from the EEG BDF file. This little pulse, however, that we see here, that's coming from the live track data. So now what we're looking at here is the alignment of that trigger pulse with the live track data. Let's look ahead to some other events later on. Let's just pick some events. Let's say that one. Okay, let's picking it kind of at random, and just want it to be somewhere in the middle. Okay, so here we can see that these events are aligned. Now, if you wanted to verify that the timing looks good, if you wanted to verify that the codes are correct, so we could go here to superimposed mode. I can change this display here a little bit to be, let's say, 25 up here. Okay, now you can see that the heights of these trigger codes are different. So it's not just the timing, but here, since our script scaled the trigger channel by 10 to the minus 6th, and EMSE uses volts as its default scale, we see now we're on a microvolt scale, and you can see this code of 125. The timing is good, and we can just verify that 125 corresponds over here to 125 microvolts, and you can see these have different heights. So this one corresponds, the height of this is 109, this is 121, and so forth. 131, 127. Okay, so that's how you can verify that the codes, the timing is good, but the codes are also correct. Since this is a relatively long recording, we might want to go all the way to the end, or close to the end. Let's say out here. So now we're very close to the end of the data. Let's see if the alignment is still looking good out there. Did I do that right? Let's see. I think I did something wrong. Let's say go to. Oh, I must not have said go to. Here we are. Okay. Now we're way out to the end of the data. I'm just going to shift it over a little bit so we're not overlapping with the trigger, and we can see the timing is good. And if you want to verify that the values match the codes, you can do that. Okay, so having done that, that's the trigger channel. Let's turn off. Let's go back to chart recorder mode. Let's turn off the trigger channel. Let's see. Let's turn everybody back on. Let's turn off the trigger channel. We've looked at that. Let's turn off the ECG channel. And we can see here that there are DC drifts in the data. If we look down here, we can see the pupil channels. We're not seeing the gaze position channels. Although we're not going to do any analysis, but just for the sake of bringing these channels back into sort of centering them in the screen, let's just do a little bit of a high-pass filter. Let's say 0.2 hertz. We can do that to everybody except the trigger channel. Okay, and let's go back to a 100 value up here. Okay, so now we can see the EEG. By the way, these the names of these channels were abbreviated from those that were in the live track data. That's because the BDF file has a maximum number of characters. So these are abbreviated, but I think you can tell what they mean. The X, I gave the X's a blue. You can give them whatever colors you want, but I gave the X's blue. You can see the blue traces are tracking with each other. And the red or the Y. Okay, so what's all this? Okay, so let's mark this. Here, we've got some EOG channels here, evidently. So I'm guessing that this is where the live track data went dark because I believe the participant blinked. So let's look up here. Indeed, here we are. We've got the frontal channels. Here we can see there's a blink. There we have some more frontal channels here. On the right side, yes, we see there's a blink. So not only do the event codes line up, but we can see that the blink events are lining up with the times when the live track can't track the eye movements because the eyelids are closed. Okay, let's just look one more case. Okay, here's another example. Let me select that. Once again, I think we've got a blink here from the EOG channels. Let's go up here. Yes, we're seeing blink. See there. Okay, so this is a blink event. Okay, so there you have it.